Okay. A great man once said, "It is far better to grasp the universe as it really is than to persist in delusion, however satisfying and reassuring." These words were said by the famous Carl Sagan. Hello, everyone. Thank you for being here with us today. Our topic is one that might sound a little out of the world, quite literally. We are diving into space weather forecasting and monitoring. We are team number 9, and I am Robin, along with my teammates Sanjay, Nikunj, and Varshan. Over the next few minutes, we will take you on a small journey from the sun to the earth, explaining how invisible storms in space can have visible effects on our everyday lives. It is fascinating emerging field, something between space science, technology, and data forecasting, and it's becoming more relevant year by year. So let's start with focus. So let's start with the motivation. So why did we choose this topic? Well, space weather might not sound like something that affects you or me directly, but it really does. Imagine waking up one day and finding your GPS not working, flights grounded, and power grids unstable. That's not science fiction. These things have actually happened due to solar storms. Back in 1989, a geomagnetic storm knocked out power across Quebec in less than 2 minutes. And just a couple of years ago, a mild storm caused 40 new Starlink satellites to burn up before even reaching the orbit. These examples show that as our world becomes more dependent on satellites and digital systems, the sun, yes, our own star, can disrupt it all. So, being able to forecast and prepare for these events is no longer optional, it is a necessity. Next, we will move towards the agenda. Here's what we will walk you through today. First, we will get into what space weather actually is and the technology behind forecasting it. That's the essence of our topic. Then, we will talk about where this technology currently stands, its readiness level, and what challenges it faces. Next, we will explore how it benefits both society and businesses, and then move into the demonstrations and case studies that show how all this theory comes to life. Finally, we will wrap up with some key takeaways, the why it matters part that ties it all together. So let's go ahead with the understanding of the space weather itself. Space weather refers to the conditions in near Earth space that are influenced by the sun's activity. Things like solar flares, coronal mass ejections, and bursts of charged particles. When these events reach Earth, they interact with our planet's magnetic field, sometimes causing beautiful auroras, but also not so beautifully, messing with our satellites and communications. Think of it as weather, but instead of rain or wind, we are dealing with plasma, radiation, and magnetic storms. Forecasting space weather is basically about detecting these solar changes and predicting how they will affect our own Earth. Next, we will move on to space weather effects. So, what happens when space weather hits? Satellites can get damaged by high energy particles. GPS and radio signals can be distorted. Airlines flying over polar routes can lose communication, and even power grids on the ground can overload. The scary part is that these storms aren't rare. Minor events happened multiple times a year. That's why scientists are developing forecasting systems just like we have for normal weather to predict and mitigate these risks in real time. Now that we have seen what space weather is and why it matters, Sanjay will walk us through how this technology actually works, the systems, the data, and the science behind predicting these solar storms. So, Sanjay, please take away.
Thank you, Robin. So now we discuss how space weather forecasting work. All right, let's look how forecasting actually happen. It starts with data and many more things. Data that like NASA Solar Dynamic Observatory, SAHO, and this discover consistently watch the sun, capture capturing the magnetic activity, solar wind, and radiation level on the Earth. The ground station track a magnosphere and ionosphere together. The system creates a steady flow and raw data. The data that's run through the complex computer models, and the magnet hydrodynamic ones. They simulate how solar wind and magnetic field behave when they Earth travel. The result turn into a dashboard that give a real-time data, and you can think them like a weather app on space. So now we discuss second point, the key organization system. So yeah, this is haven't done by any country or any agency. It's a global collaboration. The NOAA Space Weather Prediction Center in US provide a daily forecast, while a European Space Agency it has their own space simulation awareness program. Satellites such as SAHO, Discover, and Magnometer network around the world feed data those models. When the solar flare or CME detected, this agency issue the alert through the airlines, satellite operators, and the power company. In short, the ecosystem, a mix of satellites, data center, and ground instrument, keep them model infrastructure safe and keep us informed. So now we discuss second point, role of AI and machine learning. Now, there is a thing which even more interesting now. In past few years, artificial intelligence have entered in our life. So scientists are training a neural network detected earlier signs solar flares before they even occurs. AI can analyze thousands of images from solar observatory every day and find the patterns of human might miss. For instance, it can learn a certain magnetic informative information of the sun trend, leads and eruption within hour or day. Kind of predictive modeling could give an operators an earlier warning, imagine knowing 2 days ahead a major storm on the way. That's the power of combining the traditional physics and data drive intelligence. So now we discussed about a technical readiness level. So where we are now the terms of readiness. The satellites are monitoring system. Those are fully operational and tested. So we call them TRL-9. Ground-based monitoring physical model are around TRL-8, reliable but improving. AI-based prediction models between TRL-4 and TRL-6. Means they are still experiment, but they are showing a huge promises. So while we are observing the Trek solar storm very well, occurring the predictions before it's happened. So my colleague Nikunj discussed a few points about it. So Nikunj,
Thank you, Sanjay. Now we discuss about scientific limitation. When it comes to the sun, the biggest problem is unpredictability. The sun's magnetic behavior is chaotic and our models cannot yet simulate every twist and turn. Coronal mass injection. Those huge bursts of plasma are especially tricky to forecast because they depend on small magnetic changes deep within the suns. Even with modern instruments, we still struggle to capture all the variables accurately. So scientists are constantly refining models and using AI to bridge the gaps. The next part is technical limitation. Technically speaking, the volume of data we are dealing with enormous. Space weather models process millions of data points every minute, and the simulation themselves can take hours to run. This means real-time forecasting is a major challenge. A delay of even 5 minutes can make the difference between catching a solar storm in time or missing it. There is also all data latency. Sometimes satellite readings take minutes to reach Earth, which slows down to response time. Researchers are working on it using cloud computing edge AI system to process this data faster and more efficiently. The next part is organizational limitation. Now beyond science and tech, there is the issue of coordination. Different space weather centers around the world don't always use the same standards for the data sharing and model output. That means one agency might predict a storm while another rates it might. To fix that, there is an ongoing effort to standardize format and collaborate more openly because space weather doesn't recognize border. Now we discuss about societal values. Let's talk about the impact. Accurate space weather forecasting helps protect astronauts on missions, aviation crews flying near the poles, and power grid operators here on Earth. It keeps essential service like GPS, emergency communication, and transportation system running smoothly. In a world so connected, even a short disruption can cause ripple effects across economies. The next part is business value. There is also growing business values. Companies like SpaceX, issuers, and telecom providers depend on this forecast. Forecasting helps to reduce losses, plan upper launches windows, and even price risk more accurately. So space weather is not just science; it's becoming an entire service industry, one that supports the global digital economy. And now version will bring everything together, showing how this technology looks in practice with live demonstration and real world case studies.
Thank you, Nikunt. Okay, here I would like to most interesting topic about demonstration and case studies. Whatever seeing here is the real screenshot from the NOA, and also NOA is a full form of National Oceanic Atmospheric Administration. Okay, the prediction of the sensor life dash is like a mission to control a space weather. At the we have wind and density. It is signed as something big coming to the sun. In the middle of we track the instantly magnetic field or IMF, especially because of component when that active solar particles can slip into the earth magnetic shield, rising from the risk. At the bottom, the terms shows the descriptor of earth magnetic field. It's 3 gram or 4 to 5 its warning. And above the 5 means the potential of this would refers a few minutes, letting operators make quickly like switching starlights into a safe mode or turning the power loads to the product transformers. So what would like to bunch of graph actually it's a globally early warming the system. The heartbeat of monitor of chemical. Coming to the second AI forecasting visualization. Now we the futuristic part. An AI powered the power of the system is the model of deep learning, especially convolutional neural network trained the solar image from the NASA observation. The AI identified the complex magnetic patterns in the cube of the solar lights. On the left, you can see this regions highlighted in a red. Those are active parts on the right prediction output. A probability curve showing how likely the flower within next 24 hours. Instead of reaching the space weather physics based on the similar with the AI improving speed reliability the sliders the existing shift from the passive monitoring to active presence. And third point, cubic blackout in 1989. Let's connect the reality. In 1989, the massive CME struck in the Earth within 90 seconds. The cubic the great went down. 6 million of lost the power of horse. At that time, there is a no alerts, no dashboards, and no coordinates response. It was pure surprise. If that the same happened today, clouds of floats, and the prevent of major blackouts. So this is the case perfectly shows the forecasting involved from the recording to preventing to rescue. And fourth topic, Starlink stylish loss in 2022. Fast forward to 2022. SpeedX launched of 49 Starlink just a dramatic storm inflated the atmosphere. The exact drag of 49 Starlinks to the lost latitude and the burn up. And this was even a severe storm, just a moderate since the companies to like SpaceX have generated NOAA forecast directly into the mission planning. Delaying lot of the solar activity is too high. There is a perfect example of how the space awareness several aerial mania and keeps critical technology in orbit. Coming to the fifth point, takes away. To wrap the things as space weather forecasting brings together data science, atmospheric to AI certificate. Connected to the world, it's a nature to comes observation, but it's still allowing in prediction. To social value is massive. It keeps a power grid stable, flights and safe, and astronauts protected. The business sides are growing fast too. Immediately, so this field to about intelligence to making a sure technology and the survey to the power of the sun. At coming to the end, this is a reference of the NASA, NOAA, and ESA. So several research of power AI-based solar prediction. Together, they represent of the progress on goal, predicting unpredictable. Thank you for listening. We hope now you are the space weather forecasting is not just an about the space, but about in predicting a like of technology right on the earth. Thank you.